everyone, hope you're ready to learn about some conditional statements today. So a conditional statement is a statement that can be written in if-then form. So I'll just kind of draw a line over here. And we can say a lot of different conditional statements. I'll give you an example that I say at my house quite a bit. I'll say things like, you need to finish your dinner if you want dessert. So that statement could be written in if-then form. I could say, if you finish dinner, then you get dessert. And stuff like that is stuff that you've probably heard your parents say, if this happens, then this would be the result. Or it might be something more negative, like if you show up late for curfew, then you don't get to go out next weekend. Just different statements like that. So conditional statements might be said in the if-then, or they might just be able to be written in the if-then. So there's two parts of a conditional statement. The hypothesis is the if part, the thing that needs to happen in order for the conclusion, the then part, to occur. So some of the questions in this section will be as easy as just identify what is the hypothesis and the conclusion. So for this one here, if a polygon has 6 sides, then it's a hexagon. The hypothesis would be the polygon has 6 sides. And you wouldn't have to include the word if. You could just write the hypothesis is a polygon has 6 sides, and the conclusion is it's a hexagon. For this next part, this next sentence here, it doesn't have a if this, then this. It's kind of written out a different way. It says, another concert will be scheduled if the first one is sold out. So what you might need to do first is write this in if-then form. So if I'm looking at this and if I want to write it in if-then form, I could write if the first concert is sold out, then another will be rescheduled. And for this one, the hypothesis then would be the if part. So the hypothesis is the first concert is sold out. And the conclusion is that another will be rescheduled. And I don't know if you can hear the boys in the background, but they're arguing about Pokemon cards right now. So if the first concert is sold out, then another will be rescheduled. Hypothesis is the if part, conclusion is the then part. The next set of instructions that you'll encounter is they will ask you to write things in if-then form. So they'll just have a statement for you. So 4 quarters can be exchanged for a $1 bill. When you write things in if-then form, you may have to add some words to make this make sense. So I might say something like, if you have 4 quarters, then they can be exchanged for a $1 bill. So if you just said like, if 4 quarters then can be exchanged for a $1 bill, that just doesn't really make sense as a sentence. So you might have to add some things. I'm not going to be super picky about punctuation and everything, but just making it make sense as a sentence is important. Okay, I had copied this right out of your book. One reason is just to kind of summarize things for you. So let's go ahead and look at this. It says we have a hypothesis, we have a conclusion, and this kind of looks like the truth tables that we did in the last section. So if the hypothesis is if Tom finishes homework, then he cleans his room. So this would be a true conditional if he does finish his homework and he does clean the room. Okay. If this were he finished his homework but he did not clean his room, then this would be a false conditional if the first part's true and the second part's false. Now, this is where it gets a little tricky. When the first part is false, if you're saying if he finishes his homework, but if that doesn't actually happen, we really have no way of telling if this is a true or false statement. But logic would dictate that if something's not false, by defect, it becomes true. So just that, the fact that you can't prove that it's false, by default it becomes true, can get really interesting when we're doing specific examples. And you'll see one of those in the next grouping. Let's look at these examples. The directions say determine the truth value, and only if it's false do we need to give a counterexample, or an example that would show that it's false. So this first one here, if you subtract a whole number from another whole number, so you have to kind of remember what whole numbers are. Those are numbers like 1, 2, 3, 4, that includes 0 also, but everything from 0 up without any decimals or fractions. So if I subtract a whole number from another whole number, we have to read this as then or the result will also be a whole number. So I can think of a lot of examples that this works for, like 5 minus 6 is 4, and 12 minus 1 is 11. But does this work all of the time? And the answer to that is no. So the truth value would be that this is a false statement because it doesn't work all the time. And we want an example of something where we're subtracting a whole number from another whole number, but the result is not a whole number. So maybe like 6 minus 10. If I just flip that around, the result is -4, and this could be my counterexample. I just need to list one because that's all it takes to prove something is false. So this next one here, if last month was February, then this month is March, and that would be true. Because if last month was February, then the next one just in that sequence is March. Okay, and then this last one, this is what I was talking about with that last chart, where we have something here with the hypothesis, something that's kind of unusual. It says, when a rectangle has an obtuse angle, then it is called an elephant, or just it is called an elephant. So looking at this, if a rectangle had an obtuse angle, this hypothesis is false. So this is kind of one of those weird scenarios where if you start with something that's false, you can't prove that it's not false. And if it's not false, that makes it true. And I know this is kind of confusing, and this is kind of one of those like weird logic laws or kind of like loopholes. So because the hypothesis is false, because a rectangle cannot have an obtuse angle, because if you think about like a rectangle, all of those angles would be right 90-degree angles. So because the hypothesis is false, then the statement is true. And you can have some fun with your friends with like these logic things. You know, if I say like 5 plus 7 equals 0, then I am a billionaire. And technically that's not false, therefore it would be true. And I mean, obviously this isn't going to be something that we're going to be looking at a whole lot, but it is one of these rules of logic that I think it's kind of just fun to know. And here's the last part of this lesson. This chart here is in your books, and I'm not going to write all of this stuff out, but I'm going to kind of underline what I want you to have in your notes. So we have our conditional, and the conditional can be written in the form if, then. So they use just the letters P, Q. So if P, then Q. So if you write down that a conditional statement is if P, then Q, or if you want to write it with the symbols, this would just mean that P implies Q. So what I can do then is I can rearrange these into converse, inverse, and contrapositive. So the converse is formed by exchanging the hypothesis and the conclusion. So what you do is you just take those two things and flip-flop them around. So whatever the conclusion was becomes the hypothesis, and whatever the hypothesis was becomes the conclusion. So looking at this example, if the measure of angle A is 35 degrees, then angle A is an acute angle. Well, they just take those two things and flip-flop the order. So if angle A is an acute angle, then angle A is 35 degrees. For the inverse is formed by you negate both, and it's in the same order. So if you just want to write inverse, you negate both and maybe write it out in symbols. It's the same order, but you just say it's not P and it's not Q. So here for this example, if the measure of angle A is not 35, then angle A is not an acute angle. And then the last one, the contrapositive, is formed when you negate both and you switch things around. I'll just write switch order. They wrote here, you negate both the hypothesis and conclusion of the converse. So the converse switches the order, or exchanges the order, and that would just be negating the converse. This is what it would look like as a symbol, and it would read, if angle A is not an acute angle, then angle A is not 35 degrees. So let's actually do a couple more of these just so I can show you. If two angles are congruent, then they have the same measure. So what the converse would do is the converse would just flip-flop that order. So it would read, if two angles have the same measure, then they are congruent. And the directions for these will ask you to write them out, and then they'll also ask you to write out the truth value. So this would be a true statement. If two angles have the same measure, then they are congruent. That would be true. So the inverse, we have to remember that you negate. So it's the same order, just negated. So this would read, if two angles are not congruent, then they don't have the same measure. So if two things are not congruent, they would not have the same measure. That is also true. And then the last one here, contrapositive, you do both. You flip the order and you negate. So this one would read, if two angles do not have the same measure, then they are not congruent. And this one here would also be true. And in this last example, what I decided to do was give you a statement that was not already in if-then form. So we could write it that way. This one says a hamster is a rodent. If I write if, let's make this an animal is a hamster, then it's a rodent. You need to have this sentence make some sense. If you just say if hamster, then rodent, that won't be acceptable. So the converse of this is we're switching the order, and this would read if, and let's just keep the subject of this sentence up front. If an animal is a rodent, then it's a hamster. So thinking of truth value for these, hamsters are rodents, so that first statement's true. But this one here, this would read, if an animal is a rodent, then it's a hamster. You need to kind of think about this as, if an animal is a rodent, then it has to be a hamster. It's like this is the only conclusion there is for the fact that the animal's a rodent. And that's not true all the time. It could be a hamster, but it doesn't have to be. So what you're going to think is you're going to think, okay, what is another example of this? What is another, Okay, well, I'll help you tie them later, okay? Okay. So this is a false statement because you could have a different type of rodent. So you just have to come up with one specific one. I'll say a mouse. The inverse is negated. So you negate, or if you want to draw the symbol for that, it's the negation of the original. So if an animal is not a hamster, then it's not a rodent. So you need something that's not a hamster, but it is a rodent. And this would also be false. And a mouse could be another counterexample, or you could pick a different type of rodent. In the contrapositive, you're basically putting these two and putting them together. So this would read, if an animal is not a rodent, then it's not a hamster. And this would be true. Because if it's not a rodent, then it can't be a hamster, and you're all set. This one here is a little easier to see some things that are logically equivalent. This will always be true. So sometimes it's kind of hard to tell if the inverse is true or false. If you can tell if the converse is true or false, these will always be logically equivalent. So what that means is that if one of the statements is true, the other one will also always be true. So because these were both true, these were both false, and the last one, all of them were true, and it just kind of ends that way also. But they will be equivalent of each other. So the converse and inverse will be the same truth value, and the original and the contrapositive will always be the same truth value. Hope this helps, and I'm looking forward to helping you guys in class.